So now that we have this, we're gonna go ahead and continue with our beautiful lesson for today. So let me go ahead and clear out. And our learning objective is to apply the inverse trigonometric ratio of sine, cosine, and beautiful tangent. So I need you guys to take out your beautiful flip book. So take out your beautiful flip book so we can go ahead and get started with today. Everybody has it. I made you guys glue it onto your notebooks yesterday so you guys don't lose them. We're gonna, and the flip book, yes, today, yes. Only on the flip book. Okay, ready?
Yeah.
Okay, so our next tab, guys, there was a fifth tab. So we had the blue one, the green one, the yellow one, and then we're left on the last green one. We're gonna go ahead and title it Inverse Trigonometric Ratios, okay? So go ahead and grab your pencil, title it Inverse Trigonometric Ratio. All right, so let me go ahead and pause. So let's go ahead and continue. So our question for today is, how can we find the angle measurement of a right triangle? So here in this case, we have a triangle, right? Yeah. And it happens to be a right triangle. We have some sides that are given, 4 and 5. And what happens here? We have an angle measure missing. So we're gonna go ahead and use our trig functions that we are, trig ratios, goodness gracious, trig ratios that we already learned to help us find what that angle measurement is. Now, what we're gonna go ahead and do is that we're gonna go ahead and do the inverse of their operation. So before we would have an angle measurement, we would use our table with that angle measurement and find what either the sine, cosine, or tangent it was. Now we're gonna go backwards. We're gonna go ahead and find what the cosine tangent is, cosine and tangent is from the table, and then we're gonna go ahead and find what angle it's equal to. So with that said, we're gonna go ahead and write down our inverse trigonometric ratio. So you have your books in front of you, right? I don't have my book in front of me. So we're gonna go ahead and open it up on that tab that we just titled inverse trig ratios. We're gonna go ahead and split our section into 4 parts, okay? 4 parts. So we're gonna have 2 on the top, 2 on the yellow parts, and then 2 on the, is it green? Yeah, 2 on the green. 2 on the green, 2 on the, so imagine that we have this. So we're gonna go ahead and write on the yellow part. So imagine that we have this right here. My beautiful yellow part and my beautiful green part, like this, a little bit longer. We're gonna go ahead and section the pieces into 4 separate pieces. You don't need to write any lines on it, but I'm just letting you guys know that we're gonna write something here, something here, something here, and something here, correct? Okay, all right, so let me go ahead and clear now. So in my first section, right here in this little section right here, we're gonna go ahead and write the following items. Let me go ahead and clear. In order for us to write or find what the angle measurement is of something, using the trig functions, we're gonna go ahead and use something that we have, or we know as inverse trigonometric ratio. And the first one that we have here is sine inverse of our beautiful ratio that we're gonna go ahead and find. Now, sine inverse is basically the step backwards of using the, or taking the sine of an angle measurement. So the way that we write this is that it's going to be to the, not exponent of -1, but it's going to state that it's the inverse of sine in this case. So sine inverse and then our ratio. Yes, go ahead and write that in that first little corner that I told you guys. Our second one is cosine inverse. And the last one, inverse tangent of our ratio. So these are our 3 ratios that we're going to go ahead and look at today. Inverse ratios. No, all in the same little section. Okay. Now, you guys remember what sine stand for, right? It's ratio. Opposite over hypotenuse. Therefore, instead of now being next to theta, it's going to be next to our ratio. And our ratio is opposite over, so our ratio is going to be opposite over hypotenuse. In result, we're going to have our angle measurement. So theta is going to be equal to the sine inverse of the ratio of opposite over hypotenuse. Next one is cosine. That was our ka. And we said this one was adjacent over hypotenuse. So we have our ratio adjacent over hypotenuse. And this is going to also give us a result of our angle measurement, theta. And the last one, so this is the ratio of opposite over adjacent. I'm writing adjective. There you go, adjacent. And this is also going to give us a result, the angle measurement that we want, or that we need, that we're looking for. Okay. So instead of taking the sine of theta, we're going to go ahead and take the inverse sine of the ratio instead. Ready for our first example? Okay, everybody has it down? I can move on? Okay, perfect. Now we're going to go ahead and go on to our next little box. Since we already have that first box filled in, we're going to go ahead and move on to the next box. In the next yellow box. So this is our first example. Example number 1, use the inverse trigonometric ratios of sine, cosine, or tangent to calculate the indicated missing angle measurement. We're going to go ahead and round to the nearest degree. We have our beautiful triangle that we had written on our example with sides 5 and 4 and a missing angle measurement. Go ahead and copy this down on your flipboard. So this is what we're going to go ahead and do. We're going to go ahead and label that missing angle theta. So let's go ahead and label it theta, since that's the angle measurement that we're trying to look for. Now we're given the sides 5 and 4. According to this angle measurement or this angle placement right here, what is side 4 considered to be? Is it considered to be the adjacent, opposite, or hypotenuse? Opposite. Therefore, 5 is going to be considered to be. So from the 3 ratios that we have, sine, cosine, and tangent, which one are we going to use? Sine. We have opposite over hypotenuse. So we're going to go ahead and write it like we're going to go ahead and usually write it out. So sine of theta equals, this time we're going to have a complete ratio. We're not going to have a missing part. So we're going to write 4 over 5. This is where our inverse operation comes in. So we're going to go ahead and do the inverse of my left side, sine inverse. And I have to apply the same exact inverse on my right side. This cancels out my sine on my left side, and my right side I'm left with theta, which is what I want, the angle measurement. And I'm left with my sine inverse. Go ahead. Sine inverse of my ratio 4 over beautiful 5. Not too bad, huh? No, not that's it. Now, we have 2 options here. We have a table, correct? And we also have a calculator. So I'm going to go ahead and show you guys both ways. So take out your table first. So go ahead and take out your table. The ratio, it was 4 over 5, right? If I were to write the decimal value of that, it would be what? What would be 4 divided by 5? Not 0.75, 0.8 in this case. So we have sine inverse of 0.8. Now, because we have the sine inverse of 0.8, we're going to go ahead and look into our table. So here's my table. And we're going to go ahead and look at our, go ahead and share on my side. It's gracious. I'm trying to show it here. I'm gonna go ahead and look at my beautiful I'm gonna go ahead and look at my table. So sine of my angle, I'm gonna go ahead and look at one of the values that approximates the closest to 0.8. So I'm gonna start with 0. So 0, 0, 1, 0.1, it goes on, 0.1, 0.1, 0.1, 0.2, 0.3, 0.4, 5, 6, 0.7, 0.707, 7.1. It continues all the way to 54 and 53. This one is 0.798 and so on and so forth. So if we were to round it up, it would be 0.8, and 54, it would be at 0.8090. So our angle has to be in between 53 and 54 degrees. So that's using our table. Let me go back to my beautiful table. So let me go ahead and show this. So instead of writing theta equals inverse sine of 4/5, I'm going to go ahead and write it to decimal value. So theta equals sine inverse of 0.8. And if we use a table, it would be approximately 54 degrees. All right, that's using the table. Now, our calculator, of course, is accurate to the point. So you guys have calculators in front of you? If you guys need a calculator, there's some calculators up there. You guys can go ahead and grab some. Your phone, guys, be careful if you guys use your phone. There's some items that you guys will be confused with there, okay? If you guys are using your Chromebook, you can go ahead and go on to decimals.com scientific calculator. And here's my beautiful scientific calculator. So I'm gonna go ahead and use my scientific calculator, okay? So in your calculators, you're gonna go ahead and see your functions. Sometimes you have to press shift or you have to press second. And you have to look for the symbol that says sine inverse. You see it right here? On your calculator, do you guys see it as well? Perfect. So I'm gonna go ahead and press sine inverse. I'm gonna go back. I need to write 4 divided by 5. I need to close my parentheses over here and it gives me, what's my angle of measurement? 53.13. So it would be over here more accurate. It would be 53.13. So let me go ahead and see. It has to be rounded up to our nearest degree. So it would be again 54 degrees. So we can say using calculator. You can say 53, but it's using to the nearest degree. So we would round it up to 54 degrees. So equals 53.13. So therefore theta has to equal 54 degrees. Not too bad, huh? Not too bad. Ready for another example? And then I'll give you guys the worksheet so you guys can work on it. Oh, something that I forgot to mention earlier, guys. Whenever you guys have the inverse and you have a ratio right here, for example, this one was opposite over hypotenuse. This can be either given as a fraction and sometimes it can be given as a decimal value. Okay, so in this case, we had a fraction. Obviously, we had it from our triangle, but sometimes you're going to be given it as a decimal value, which again, it's as a representative as a fraction. We can go ahead and transform the decimal into a fraction. All right, here's our next example. Ready? I'm going clear. Go ahead and try this one out. Example number 2, we have our triangle, we have our sides 10, 8, and we have our beautiful angle missing. It's a different, yeah. So go ahead and do this one out in your green area. In the green area. So we have our triangle with sides 8, 10. And we're gonna go ahead and label the bottom one now as our beautiful theta. So this is now our beautiful theta. Okay. All right. So by looking at this ratio, which one are we going to use? cosine. So we have adjacent over beautiful hypotenuse. So therefore cosine of, what do I write next? Theta equals 8 over beautiful 10. So how do I get rid of that cosine on my left side? Inverse, so I have to do inverse cosine on both sides. Inverse cosine. So we're left with theta equals inverse cosine of my ratio 8 over 10. So what's the decimal value for this? 0.8 again. So in my table, you can go ahead and look for cosine of my angle that approximates the most to 0.8, or you can go ahead and use your calculator and do the inverse cosine of 0.8 or 8 divided by 10. You guys decide. Let's see what you guys get. Go ahead and find. So what did you guys get? So I have theta equals cosine inverse of 0.8. If we look at our table, let me go ahead and bring up my table. Here's my beautiful table. Let me go ahead and clear this out so I can see very quickly. I have cosine of my angle and it starts with 1. So I'm going to go ahead and work my way down. I have 0.9 all the way down to more. Right here it goes to 0.7. So it has to be 36 or it's already at 0.8. I'm going to have to go with 37 since we can go ahead and round up the value of that ratio. So it'll be between 36 and 37. So I'm gonna go ahead and round up with their angle measurement. Let me bring everything out. Let me share my screen, make sure everything's there. And therefore theta equals 37 degrees. Don't forget your degree sign. Now, if I were to use my scientific calculator, let me go ahead and clear. Here is my scientific calculator. Let me go ahead and clear all. I have my inverse functions, cosine inverse. I have to divide 8 divided by. I have to go outside and close my parentheses, and I have 36.86. So therefore, round up, it would be 37 degrees. That would be correct. Raise your hand if you got that. Woo-hoo. Not too bad, huh? Do you guys want to try the last one on your own? Awesome. Okay. Let me bring out the example. Yeah, that's just, yeah. The rest, we're going to go ahead and do the next, not tomorrow, but probably Monday. So here's the last example for you guys. That's the last box that we have. Example number 3, use the inverse trigonometric ratios of sine, cosine, or tangent to calculate the indicated missing angle measurement. Round to the nearest degree. This time we have our beautiful triangle with sides 16 and 22. And our beautiful theta is down here. So go ahead and find the angle measurement of that beautiful angle. We're going to go ahead and label these sides adjacent over opposite. So we have tangent theta equals 22 over beautiful 16 since we have TOA. Now we're going to go ahead and do our inverse. Tangent inverse. Tangent inverse. This eliminates my beautiful tangent over here on my left side. So we're left with theta equals tangent inverse. What is the decimal value of 22 divided by 16? You guys have your calculators. It would be 375. Now we have 2 options, either use a calculator or use our table. I'm going to go ahead and use a calculator this time. So let me go ahead and bring it up. Let me go ahead and clear this. We have our beautiful function, inverse of 22 divided by 16. And my angle should be 53.97. Rounded up, it should give me beautiful 54 degrees. So theta equals 53.97. Rounded up to nearest degree, so theta equals 54 degrees. Woohoo! Not too bad, huh? All right, so I gave you guys your worksheets, correct? Okay, so go ahead and complete them, guys. You can go ahead and use your table, or you can go ahead and use your calculator, whichever one you prefer. Take the pass. But I'm giving you guys class time to complete all of this. Yes.